we add with sine and cos either plus 180 or either minus 180 to change the sign. Am I right, sir?
Yes.
So
Yes,
in
that's
any
correct.
case, if there is omega t, if there is omega t minus 30, and then I want to change the sign, then if I add plus 180, then it will be eventually plus 150 degree, right, sir?
Yes, perfectly correct.
And if I add minus 180 degree, then it will be minus 190 degree, right, sir?
So your question is, should we go for plus 180 or minus 180? Is it your question?
Exactly, sir. Because I was doing one of the pop quizzes and my result was plus 150 and they had minus 190, and I didn't understand. Like, my phase difference also was different from them. So I actually couldn't get the concept.
You didn't get the concept.
Sir,
All
like
right.
my math was
So
different. So I didn't understand.
okay. So look, the question is, the both in both cases you will get the same answer. If I say something is 0 degree and some other people are actually saying that is 360 degree, is there any difference?
No, sir, there's no difference.
All right. So, okay, I will explain this thing actually in the class. Then everything will be actually okay. Means, if I say, like current is leading in a voltage by 50 degree, I can also say current is lagging actually voltage by 360 degree minus 50 degree, something like this. So I will try to explain this thing actually more in the class session, maybe end of the session. Then everything will be clarified. Because if I don't write, you will not understand like what is happening.
Okay,
So
sure,
yeah.
sir. I have
Any other
another
question other
request.
than that? Yes, it's a good question. Yes, sure.
Sir, I actually forgot how to add polar, like in complex number, how to add the polar part, like the how to add the
Okay.
basically the angles and the radius basically are.
Okay.
I just forgot. I searched many
For the
videos, but
magnitudes.
I
So
didn't get it exactly, sir. So
so
in this class,
you need
will you please show?
you need help. Yeah, today's class, I will be focusing on, the phasor. Like we'll be discussing about the whole complex number, things as well as
Yes, sir.
phasor. Because whatever we are learning right now, there's just the basic, and will not be using, that sinusoidal or cosine things, for a long time. So maybe after, two or three more classes, everything will be, based on, the phasors. So the complex numbers. So we'll be having, this sort of things. So yeah, today we'll actually clarify all of this. No problem.
Yes, sir, please
Is there
just
any other question?
show the
Yes,
addition,
sure.
because in the videos there
Thanks
is
for you.
they
Actually,
didn't
yeah.
show. And I checked your
Actually,
lecture
I am not
notes.
supposed to actually.
Yes, sir.
So what I wanted to say, I supposed not to discuss about phasor in the last class, since somebody asked some silly question like the verification of KVL or KCL, like how would we do these things. That's why I bring back the idea of phasor or the impedance relation things. So otherwise, I wouldn't actually use phasor so far. Means I have been waiting for to for the phasor as well as the things you mentioned earlier, like how to do the multiplication or summation or a subtraction in complex number. Means how would you treat the radius as well as the angles. So today probably we'll be actually discussing this, but why are we having so less student? It's already 3 minutes. 3 minutes actually past 2:30. Sorry, not 2:30, 12:30. We'll be waiting for few more actually student to join. Then we'll actually start our session. Is there any more question from the previous classes or anything?
No, sir. Till then, now. till then, it's the only question that I have.
That's good. Why the number of students are so less? Like, is it because I don't take attendance, or they have other classes to join, or other exam to attend, or something? No idea. If this is the case,
Sir,
maybe I need to take attendance from the next classes. Huh? Okay, no problem. We may actually start. Whoever is not attending in the live session, they can always check my recorded session. I have started recording probably. I will be actually presenting now. So let me actually share my screen. uh, is my PDF file visible?
Yes, sir.
Can you see the PDF file here?
yes, sir.
Thank you. And I'm audible, right? Okay, that is so
Yes, sir.
great. Okay, so from the last class, we had been discussing about the behavior in actually purely resistive circuit, purely inductive circuit, as well as actually purely capacitive circuit. Also, we talked about some RLC circuit and how to actually calculate the voltage current relation in different ways. We have learned that we can solve such equation in the either using actually the phasor form or the reactance actually formula. We have actually done this. So we have learned so far, like if I have a circuit, a simple circuit so far, then we can easily calculate what is the relation of voltage as well as the current in that branch. Once we actually know the voltage expression or sinusoidal or the AC actually voltage as well as the AC current in a circuit, then we can calculate two more actually terms which are really important. We call it actually instantaneous power as well as actually average power. So what does it mean? What does it mean? So the name suggests, like when we say that, let me actually draw. So instantaneous power means the power at a given time, like given time. So let's say that means there will be a part, the power expression will be having a term which is dependent upon actually time. So if we change time, then the instantaneous power will change. In the same way, there is another thing called the average power. This power is independent of time. What does it mean? Like there will be a part, we'll see how to actually get that. Independent of time means it's not a function of time. So in this class actually we'll be focusing on two general things, like we'll be discussing about the power, average power, as well as actually some the phasor things like the complex number, or how to actually deal with actually complex number. So in order to do so, just think about a circuit. We don't know the circuit. It's just a black box. It could be a RLC circuit, it could be RC circuit, or else circuit, whatever, the circuit. In that circuit, we can calculate, we can actually get the expression for voltage. Since it's a AC actually voltage, so in general term, the expression should be something like the maximum value, followed by sine or cosine, and there will be a phase difference. This phase difference could be negative, could be positive, could be 360 degree or any values. So in general, we actually define the expression with actually theta v. Theta v is the phase voltage, like the voltage for phase angle for the voltage expression, as well as in similar fashion we can actually express the instantaneous current in that actually given circuit by this like Im sine omega t plus theta I, where theta I the actually phase angle for the current expression. So we already know that, but these are the what is it called, the general generalized actually expression. So Im and Vm actually represents the maximum actually voltage or maximum magnitude of voltage and current respectively, and theta v theta I are the phase angles of the voltage and current respectively. So if this one is the case, we need to calculate what is the instantaneous power. Means since that voltage is a function of time as well as current is function of time, so we can actually expect that power would be also a function of time. So if we recall the basic we have learned, the formula for power is voltage times current in DC. When you have studied the DC circuit, we have calculated power using the voltage time current, or V square by R. Some people say this is so some people say V square by R, some people say I square by I square R, or something like this, using just Ohm's law with the V equal to R, P equal to V times I. So now in the AC circuit, since the power, voltage and current are a function of actually time, so what we will do, we'll calculate the instantaneous power, means the time dependent power, in the similar fashion. So what we did, we took actually instantaneous voltage as well as that instantaneous current, and we'll simply actually multiply this two. So if I do so, then this is nothing but something like this, like this is Vm. I just replaced the value of actually voltage and current here. So I took the Vm and Im in the actually front. So what we got, sine something. So if I have something, so two sinusoidal term. So my target is to decompose the time dependent part as well as the time independent part, because I said there is two terms that's called instantaneous power, and the average power means one is time dependent, another one is not time dependent. So in that case, how do you actually decompose this thing? Means omega t terms should be in one expression, and the other terms like theta v theta I terms will be in another expression. So in order to do so, we need to actually take some help from the actually trigonometric relations, and we all know that relation, like this is, if I consider the whole thing is A and whole thing as B, we can actually write down the formula like this, right? Sine A sine B equal to half cosine A minus B, or B minus A, whatever you write, minus cos A plus B. Now we all know this formula probably. If this one is the case, we just actually like use this actually relation. So I expand this relation, and the relation should be like this, like cos A minus B, cos A minus B. So this is A, this is B, this is A, this is B. So cos A minus B, and then the cos A plus B. So if I do so, then you can see this expression, one of the expression, doesn't contain any time dependent part or t dependent part, but there is another term which consists of the time dependent part. So if once we know this one equal to this, so we can replace the whole thing here, this expression here. So if I replace this expression here, so we will get something like this. It's so straightforward. If this one is the case, we'll multiply everything we'll multiply everything. So what we'll get, there is a term without actually time dependent part, and we called it actually fixed value. And in the beginning I said, that average power is in AC circuit is defined as, something independent of time. So in that expression, in the whole expression of actually power is a time dependent things. The DC part, this is called the DC part. Can you tell me why I'm saying this is a DC part? Is there any idea? This is a fixed value.
Because it's not changing
but
over
I'm
time.
also saying it's a DC part.
There is no time-dependent function.
Yeah. Yes. Thank you so much. This is DC part because it's not changing with respect to time. It's not changing also with respect to the frequency, right? Because in the AC, the time changes. That means the frequency also changes. But in this term, the first term, there was no actually time-dependent part or the frequency-dependent part. So this is also sometimes it is called actually DC part. Sometimes it's called actually fixed value, not dependent on time. And this is called the average power. This is called the average power. So this is called the average power of AC circuit. AC circuit in general expression. How about the other term? The other term changes. Other term changes with respect to time. So this is a time varying actually term, or we can say time dependent actually term. And this thing is time varying thing. So now can you tell me, this is called, the whole thing is called instantaneous power, or this one is called instantaneous power? Yes. This part only time dependent. Huh? Sorry. Can you actually repeat this? Okay, this is called the time dependent part, but the whole thing is called the instantaneous power. But in that instantaneous power, there is called something DC, and that DC part is called the average power, and the other part is called the time varying like terms. But more or less we are actually what is it called, like we are interested in the average power, because that defines how much power the device can actually generate, or that generator or some actually machine can generate. So for that average power, this is important. And why this is important? Because maybe in the next semester or the subsequent semesters, you will be taking some course on power system, like energy conversion 1, energy conversion 2, power system 1, power system 2. There are many courses, and these courses are based on this formula. Like there will be some term called power factor, some term called like how much power that machine can generate, or something like this. So in that sense, I believe I should actually clarify this in this course, so that when you will actually go for that modules, it would be so easy for you to actually grasp the idea or the general expression. So as I said, the DC part is given by the average power, and this is something like this. And interesting thing is, we can see the expression that Vm Im means the maximum value of the voltage, maximum value of the current, divided by 2 times cosine of the difference between the voltage and current, right? The difference between the voltage and current phase angles. So we can actually modify these things. So if I like replace 2 means root 2 times root 2, so we can write down Vm by root 2, Im by root 2, and cosine cos v minus theta I. So if you recall, we have actually studied like how to calculate the RMS value of a AC signal, and we have seen if it is a pure sinusoidal actually signal, then the RMS value is nothing but the maximum value divided by root 2, or sometimes it says 70.7% of the maximum value. So if this one is the case, we can write down VRMS times IRMS times cosine, and the difference between, sometimes it's only written as cos theta, sometimes it's written as cos theta, where theta equal to always the difference between the voltage and current. So that is the very expression. Now the thing is, in DC circuit, we have learned whenever we called the power, we said only V times I. But right now in AC circuit, since it changes within respect to time or the phase angle, like voltage and current doesn't in phase. So what we added here, there is a modification called like voltage time current times in a cosine terms, that cosine theta v minus theta I. You remember this term is called power factor. Power factor. What does it mean? This term is called power factor. For a given RMS value, means the voltage value, that doesn't change. For a given actually current value, the IRMS doesn't change, but the only thing changes is the like whether the whole system is leading or lagging, some sort of thing. So if this one is the case, the cosine term will actually modify the whole actually power of the system. Am I clear? Hello.
Yes, sir.
Yes, sir.
Hello. Can you hear me? Okay.
Yes, sir.
Yeah. Sometimes I feel like the internet connection is not stable or something. If you actually encounter any actually issues like you cannot hear me or something, please actually give me feedback. So if this one is the case, this one is called the power factor. Means if I modify this one, the cosine term, then we'll get actually different amount of actually power simply by varying the phase difference between the voltage and current. So let's check what would be the power expression and what would be the power in pure like system. Means the either we'll consider purely resistive circuit, purely inductive circuit, or purely capacitive circuit right now. Then we'll be studying some RLC circuit, means the combination of resistance, capacitor, inductor circuit, how to get the voltage current expression or the power factor or the total power. So now the last week we had discussed about the behavior in resistive circuit as well as inductive circuit and the capacitive circuit. If it was the case for the purely resistive circuit, we know the voltage and current are always in phase, right? Is there any confusion? Like we hadn't seen like this, if this is a voltage expression in resistive circuit, then the current expression should be like this, right? Depending on how, like we have seen this, right? Like
yes,
if we have actually voltage and current, yeah, then it would be something like this. If this one is the case, what is the phase difference between the voltage and current in resistive circuit?
0
degree.
Theta V equal to theta I, right? Yeah, we cannot say theta V equal to theta I equal to 0. Means it could be any number. It could be any number, but the difference is always 0, right? Because these two always starts from the same point. It may start from the 0. It may start from the here. If V starts from here, the I also actually starts from there. So the difference between the voltage actually and current actually phase angle is always 0. If this one is the case, what is the power factor or the cosine term here? The cos 0, right? The cos 0 means the maximum power. So what will we get is VRMS times IRMS, or if I actually express in terms of actually maximum value, then VM by 2, VMIM by 2. So what I suggest, sometimes we get confused, like should I go for the formula VMIM by 2 cos theta or VRMS IRMS cos theta? So my suggestion, go for anyone, like either go for the maximum value in the formula or RMS formula. But what I did in my time, I always remember the power means VI cos theta, but V and I are always RMS value. So if I just write down like VI cos theta, if I use this formula, remember this is RMS value, this is RMS value, not the maximum value. So if I have maximum value, I need to actually convert it to RMS value. So be careful with that. Now, if we get actually some expression like this, in the very beginning, I have written some expression like this, right? That power equal to voltage times I V square by R or I square R, we have been actually studying it from the SSC, HSC, O levels, L levels, in every levels. So let's actually verify that things. So if I write down VRMS times IRMS, then I know like IRMS equal to IRMS is written here. IRMS equal to VRMS by R. Resistance means the voltage equal to current times in the resistance, the basic actually Ohm's law. So if I actually substitute these values, we'll get VRMS square by R, IRMS square times R. So now that means resistance actually behaves in the same way in DC as well as in AC. The only difference is in DC there is no RMS value of voltage and current, but in AC we need to use the same formula for resistance, but only the value of actually voltage and current will be represented in terms of actually RMS value, not the peak value. Am I clear? It's so simple, right? It's so easy. So yes, if there is no actually question, so yeah, if there is no question, the next thing, let me check how many students are here. 11 students, not bad. So now if we actually consider a purely inductive load, if we recall closely, we had a expression like this, like if this is a voltage expression, there was a current expression. Lag means from here, if I'm not wrong, something like this, right? V and then I. So for purely inductive load, we know the current actually lags voltage by 90 degree, right? So what does it mean? Current lags voltage by 90 degree. That means this is wrong actually. This is wrong. This one would be plus. So current lags actually voltage by 90 degree. That means theta I minus theta V equal to negative 90 degree. If I'm not wrong, please check there. So if this one is the case, means I have been writing I first. So I need to write the phase angle of I first, and then the phase angle of actually voltage, and the difference between these two is negative 90 degree, since we are writing lags. So if it was leading, then it would be a positive value. Why this is wrong? I have written theta V first and then theta I second. That means if current lags actually voltage by 90 degree, that means voltage is leading actually current by 90 degree, and this should be the expression, means the plus 90 degree. But although the results will not change, because even if you put actually negative angle inside actually cosine term, still it'll get the same value, because cos negative alpha means the cos alpha, so you'll be actually ending up getting the same result. So if I actually get if I replace the theta I minus theta V or theta V minus theta I equal to 90 degree, then what would be the cos angle, like cos theta? Like we know the average value VRMS IRMS times cos theta V minus theta I. So cos 90 means 0, so the whole thing is 0. That means if you have an inductor in AC circuit, the pure inductor, there will be no average power generated. You cannot generate any power in that system, because the whole power, the average power dissipated in the inductor is 0. Similarly for the capacitive actually load, we know the for the capacitive load, the current leads actually voltage by 90 degree. So current leads actually voltage by 90 degree means theta I minus theta V equal to minus 90 degree. Please check I'm right or wrong now. Theta I minus theta V should be 90 degree, not this, if I'm not wrong. So although the results will not change. Sorry? Hello?
Sir, in the video it was also shown like this, like theta V minus theta I is equal to plus 90 in the video also, like your lecture note.
Okay, I will actually I'll recheck it once again, but I think I'm right. So the thing is,
seems to be correct.
If I put in a 90 degree here, yeah, thank you. So if I actually go for the average value, so I will just replace that the phase angle here. So 90 degree, that means again 0. The average power dissipated by the capacitor is 0. What does it mean? If we
Sir,
want
won't
to
it be
produce
minus
any
30
AC power,
degree? Or it will be 90?
all right. So if you, okay, if I go for this one, theta v minus theta I equal to minus 90 degree. But even if you put in a cos negative 90, you'll still get the same results as 0, because cos negative alpha equal to cos alpha. So what I wanted to say, let's say you are like we want to generate some AC power in a system. We can never use a purely capacitive things or purely inductive things, and it will never work, because the total average power dissipated by a capacitor is 0. Give me 1 second. Just a second. Yeah. So this one is the case, and now let's get into some real actually example. We don't know the circuit. Somehow we have derived actually the expression of voltage as well as expression of current, and there is second example with some expression of actually voltage, instantaneous voltage as well as instantaneous current. My target is to calculate the average power delivered by the network. Now, first thing first, is it RMS value or the maximum value? Can somebody?
It's the maximum value.
Perfect. Perfect. You're correct. What is the theta v here?
40
what is the
degree.
Theta I here.
Theta v is 40 and
plus or minus.
Yes, a plus 40 and plus 70.
Since we have been doing, okay, first we'll do the number A, and then we'll go for number B. So if this one is the case, as I said, although I have written in terms of actually maximum value, you can go for the P average equal to VRMS IRMS time cosine theta V minus theta I. So you can go for anything. Okay. So if you go for the VRMS IRMS, so your first task is to find VRMS. What is VRMS here? The maximum value divided by root 2, right? And similarly, the RMS value of current equal to maximum value by root 2, and then you need to replace what is theta V and theta I. So if you replace this value, or if you are using actually maximum value, you don't need to actually change into a RMS value. Then but be careful with the factor 2, otherwise it will not work. So if you put this value here, then you will get some power. So now what I wanted to say, can somebody tell me the whole system, is it a resistive system, capacitive system, or inductive system, or hybrid system? Means there might be resistor, might be capacitor, might be inductor, or combination of
it's a combination.
Sir, I guess it cannot be a resistive, like it cannot be for the resistive.
It's a
because
combination.
the potential is different. I think so.
Thank you for your opinion. So whoever was saying it's a resistive system, the answer is no, because if it was resistive system, then the voltage and current will be in phase. Means if this angle is 40 degree, then current would be at 40 degree, means phase difference. So the phase difference should be 0. So it's not a resistive system. It's neither a capacitive system, because if it was a capacitive system, then power factor angle would be 90 degree, means the real power would be 0.
There would be no power.
We discussed here. Similarly, if it was a thank you so much. So if it was a inductive circuit, then again we would actually get 0 power, but we got some finite power, and we see the phase, there is a phase difference, means the phase difference is not 0, so it's not a resistive circuit. It is a combination of resistive, inductive, capacitive circuit, or maybe it's just a capacitive inductive circuit, but it's not a purely resistive, capacitive, or inductive circuit. I think it's not that important, just for your information. Like when we are doing some mathematics, sometimes we don't want to know, like, oh, what is the implication of this, like in the real life, how can we relate it to like theory or something, experiment or anything. So similarly for the next one is the same. It's an like homework for you. Like you can actually give a try. I will not go into detail. So the maximum values are given, as well as the phase angle is -70 degree here. and negative 50 degree here. So nothing, it's so simple. So we'll just replace and we'll get some results. So also, the total phase angle is negative. Total phase angle is negative, and total phase angle is positive. So although if you check this one, what is the difference here? Negative 30 degree, right? What is the difference here? Negative 20 degree. Let's say I have a system theta v equal to 70 degree, theta I equal to 30 degree. So what is the difference? Theta v minus theta I means what I said, theta is 40 degree, right? Now, same example. I say now theta I equal to 30 degree, sorry, 70 degree, theta v equal to 30 degree. What is theta v minus theta I? Negative 40 degree, right? Any confusion so far? No. In one case, we got positive 40 degree. Another case, we got, negative 40 degree. Now, what is the cos theta value here? Cos 40 degree, right? What is the cos theta value here? Is my writing actually visible?
Yes, sir, it's visible.
Visible.
Thank you.
So it is 0.766.
0.766. You have calculator?
Sir,
Thank you so much.
0.766, sir.
Sir, basically the values are going to
Thank
be
you.
the same. Doesn't matter it's plus or minus. In case of cos.
Just give me a second. Yes. All right. So what was the value you said?
Sir, 0.766.
0.766. This one is also 0.766. Now, you see, the power factor for this system, the upper system, and the power factor for this systems are the same because we got the same cosine values. But one of the power system is leading, another one is lagging. So, for this system, for the upper system, is current leading or lagging?
Lagging. Current is lagging.
Thank you. And in this system, current? In this
Leading.
system? So current leading. So in the first system, the current is lagging. So we'll be calling it as power factor lagging. Power factor lagging. And this is called power factor. PF means power factor. P dot F means power factor. We'll be discussing it in more in the next slides actually. So power factor is leading. What I wanted to say, when you will be studying about the power system or energy conversion actually subjects, these things are really confusing. Like we got the same power factor means 0.766, but sometimes we should say, oh, this is leading or this is lagging. This is nothing. It depends on two things. Either you can check theta v minus theta I. If this is positive, that means the current is lagging, and if theta v minus theta I is negative, then the power factor is leading. Means it depends on the current. If current is leading, power factor is leading. If current is lagging, power factor is lagging. So I already discussed this one. The power factor is defined as the cosine term, because this is the term which modifies the whole power in the system. As I discussed, the power factor is given by cosine cos theta v minus theta I, and that is so easy. And how do you actually calculate the power factor if the total power is given? We know the formula, right? P average equal to V RMS times IRMS times cosine cos v minus cos I. So we'll just actually plug all the all the values of the average power as well as the average voltage and current, and then we'll get the power factor. So what is the power factor for the resistive actually network? It's so simple, right?
1.
Yes. In order to find the power factor, either I need to know what is the phase angle between the voltage and current, or we need to know what is the power as well as RMS value or the maximum value of the voltage and current. So for the resistive network, we know that voltage and currents are always in phase, means there was no phase difference. That represents the power factor would be 1. So now tell me, power factor equal to 1, is it good, or power factor 0, this is good in terms of actually power generation?
Sir, maybe
So
1.
one is good.
Mm-hmm.
1 is
Okay.
good, sir.
1 is good because yes, because that defines the maximum power, right? So unity power factor is always good, means you'll get the maximum power in the system. But in resistive system, we don't use resistive system in AC circuit, because resistance means power loss. We don't want to actually lose the power. We are not going to actually discuss it right here, but maybe in the next semester or next semester you will be learning this in details. So similarly, for the purely actually inductive or capacitive network, we know the phase angle is either positive 90 degree or negative 90 degree, depending on inductive and capacitive circuit. It doesn't matter, because overall the thing should be the cos 90 means 0. That means that there will be there will be no power factor in the system, or the real power generated in the system. So we discussed this earlier, and I have given you an example. Yeah,
Sir, 90 is
Sorry?
the difference of voltage and current,
Yes.
right, sir?
Yes, yes, yes. Yeah, that is correct. So if current leads, as I said, the leading power factor. If current lags, as I said, it's a lagging power factor. So when we say power factor, we'll get a number 0.717 or 1 or 0.5 or 0. But that power factor could be either leading or lagging, means the whole system will behave either as capacitive circuit or inductive circuit. We know in the capacitive circuit, current always leads, and in the inductive circuit, currents always actually lags. So when I say power factor is leading, it means the whole system. We don't know the system; it's a black box. Maybe there are thousands of actually capacitor, thousands of actually inductor, but whole thing as a whole, the whole network will actually behave as the capacitive network if the power factor is actually leading. If the power factor is lagging, the whole system will behave as inductive actually network. Am I clear?
Yes, sir.
If I'm clear, thank you so much. We'll actually discuss 2 more actually examples here. So if you look at this examples, so we have a voltage and current. Also, we have voltage and current here. So my target is to calculate what is the power factor of the first system. The answer is here. So I don't know. This is so simple. All you have to do is to calculate theta v, theta I. I'll take the difference between these two, and we'll get the power factor. But we need to say this is leading or lagging. How do you actually define this is leading or lagging?
Sir, just the difference, as you
If it's
have
positive,
shown.
if it's
Okay,
positive,
yes.
then it's leading.
So let's try. Okay. So from the first or second class, probably when we had been actually discussing about whether current is leading or lagging, we always have drawn the graphs, right? Then we have decided whether it is leading or lagging. But this is quite tiring, and it's not easy to do. So the easiest thing is to go for checking this theta v minus theta I. So if you write down theta v minus theta I, what is the theta v value here? Negative 20. What is the
Minus
theta
20.
I value? Oh, minus 20 or plus 20? Sorry, plus 40.
Sir, it's minus 40 eventually.
Yes, eventually. Plus 40. And this minus is the formula minus. So it means plus 20, right?
Sir, minus 70 degree.
It means plus 20? Ah, minus 70 degree.
Sir,
Yeah,
minus
quite
70
old.
degree.
It's my mistake, sorry. Minus 70 degree, right? So what does it mean? Minus 70 degree means voltage is lagging.
Sir,
Voltage is lagging current by 70 degree.
60 হবে না?
Or we can...
Isn't it 60?
Yeah, what is wrong with me?
60, sorry.
What is wrong with me? Whatever you people are saying, I just believe in it blindly. Okay, no problem. Calculation is not a matter of me in the real exam. I will not do the calculation, and probably even if you make a mistake in calculation, there will be no significant actually mark deduction. I don't believe in the numbers. So what I believe, I will check your method. Like, did you understand the whole concept or not? Even if you make some silly mistakes like this, like you have written correctly, like 20 minus plus 40, but somehow some other students has written like, let's say 70 or something, I don't mind. No, I should not say this thing, then you'll not study. Even right now, not many students are joining, only 10 students are joining because I don't take attendance. So but I may take actually sudden test, so you should actually tell your classmates or friends that sometime they should actually join the class. Any day I can take sudden test or sudden quizzes, so they may actually miss the quizzes if they don't attend. Whatever, if theta v minus theta I is a negative 60 degree, what does it mean? The voltage is leading in a current, or voltage is lagging actually current?
Voltage is lagging.
Voltage is leading.
Voltage is lagging. What does it mean?
It's negative.
Voltage is leading. Negative means you
So
see the difference is negative.
Well,
if the difference is positive, the first one is leading. If the difference is negative, first one is lagging. So if this one is the case, voltage is lagging current by 60 degree. It means current is actually leading voltage by 60 degree. Or you can check like this: theta I minus theta v is plus 60 degree. That means current is leading. So the power factor is leading. All you have to do, if I ask you to calculate power factor, you'll find this number, but you must write whether this is leading and lagging, and you need to verify this checking the phase angle of actually voltage and current. If this one is the case, the same applies for the second one. We'll actually calculate the voltage angle and the current angle here, and we'll plug everything here. And the final decision whether this is leading or lagging, we'll check the phase angle once again. Any questions so far? If not, you will be actually discussing some basic of the complex number that I think I should actually review this, because you all know, but sometimes it's good to actually clarify once again. So actually in AC circuit, we cannot do anything without the concept of phasor or the complex number. Then we can actually like solve all the problems very easily. Like we know, the complex number can be represented by two formats, and these formats one is called actually the rectangular format or the Cartesian format, and the second one is called the polar format or the phasor format. So let's say this is the origin. We want to define a position. We want to define a position of a actually like object at certain point. So how could we go? Some people say, oh, I will go here to here and then here. Or some may say, no, I don't like it. What I will do, I will go here and there, no problem, I will reach there. So there's one way. It's called the rectangular form, means you will actually move in the x-axis, then you will actually move into actually y-axis and so on. So this is called the rectangular format, and we all know that since it's a complex number, y-axis is the imaginary axis and the x-axis is the real axis. So in order to actually reach here, we need to define how long should I actually move in real axis direction and the imaginary axis direction, and this is given by this equation. I think we all know that. Similarly, I can reach here to here directly, right? Like I can reach directly. Then I need to define two things, like what is the distance between this point and this point, as well as what is the angle it generates with respect to real axis. That is important. So when we say, you know, the phase angle or angle in a complex number, it's always with respect to, you know, x-axis or the real axis. So this number we have represented in terms of actually rectangular format, means there is a x coordinate and y coordinate replaced by I, although in AC circuit will not be writing I, will be writing J instead, because I is a keyword for, you know, current. So people will be so confused. We'll replace everything by, you know, J. And we all know, you know, that J square equal to -1. We know that, right? Or I square equal to -1 in complex number. In the polar format, yeah. So, did you say something? Did anybody say something? I'm not sure. So whatever. The second thing is in the polar format. In the polar format, we can actually express in terms of a modulus or magnitudes, as well as, you know, the angle. So we all know that. You can read, you know, these things. I'm not going to actually discuss more. So there is another thing, is negative. What does it mean? Negative means, you know, the phase angle plus minus, you know, 180 degree. Because this magnitude can never be, you know, negative number. This magnitude can never be a negative number. Remember, for the polar format, Z is always positive. Z is always positive. So if I have written -5, it means the magnitude is 5, but only angle is negative. Negative means maybe in this direction. This is positive theta, like counterclockwise, maybe in the clockwise direction or something, using actually a trigonometric expression. When okay, so if this was the case, I will
It
just
means
briefly, you know, say that if you wanna.
So it means while we are plotting, then we need to convert it.
Yes, it
convert
means
the
what I
angle.
wanted to say. Yes, what I wanted to say, in the polar format, the Z is always positive because it's a modulus, or we call it actually magnitude. Sometimes we call it modulus. Sometimes we call it like, yeah, probably modulus. And this number is always, you know, positive, always positive. But that negative sign represents, you know, the phase angle, like whether the phase angle is negative or, you know, positive with respect to, you know, something. If you don't understand, I can explain, you know, more, but I think these are, you know, very basic thing we have learned in HSC level, so I'm not actually discussing in detail. So these are also, you know, very easy. It's a real axis actually magnitude, and this is the imaginary axis magnitude, so you can just, you know, need to replace. This is a purely imaginary number, so you can just replace. So similarly here, 5, then -30 degree. That means magnitude is 5, but the angle would be, you know, 30 degree with respect to x-axis in counterclockwise direction. Counterclockwise direction. So counterclockwise direction means angle positive. Clockwise direction means negative angle. So positive angles means, you know, anti-clockwise rotation or counterclockwise rotation, and negative angle means, you know, the clockwise direction. So when I say, you know, 5 angle, you know, 30 degree, so I will draw a line with, you know, radius of 5, and, you know, the what is it called, the angle should be, you know, the 30 degree, the positive 30 degree. Similarly, you know, for the next one, if I have, you know, the clockwise, you know, rotation means angle is negative. It means I will go, you know, clockwise rotation in 180 degree. Now it's a home task for you. Can you draw this thing? And can you draw this thing? You can practice actually drawing this thing. The hint is you need to actually replace that negative number inside actually the angle. Okay. So if you can do that, the answer is easy. Actually, basically, this is nothing, but this is like this. This is nothing. All right. If this one is the case, when I say -5, we have already learned how to actually convert the negative sign into the positive sign, or the -7 into the +7. So you can do again. আপনার ওয়াইফাই লাগবে? Internet লাগবে? No. So all right, we all know the now if I have a rectangular, like how to actually convert from one format to another format. Like if I have a rectangular actually system and I want to convert into the polar format, it's so easy. The rectangular coordinate is x and y, so we have to calculate the z, means the modulus, or the what is it called, the magnitude, and is given by √x² plus y square, and angle, phase angle, is tan inverse y by x. In similar fashion, the polar to rectangular is z cos theta along x-axis, and y-axis is z sin theta. Do you have any question, or I need to clarify this? If you want me to actually clarify, I can clarify.
No,
otherwise, I will just skip.
No, sir, it's fine. We all
This is
understand.
simple thing, right? Yeah.
Yes, sir.
Yeah. So if this is simple, well, not go. There is actually question that you need to convert the rectangular to polar, or polar to rectangular. No problem at all. Now, I have a question because there's a simple thing. I have a number -7, -14j. This is one question. This is another thing. If you have calculator, can anybody tell me what is the phase angle of this, and what is the phase angle of this, and what is the magnitude of this? Means express this one in polar format, this one also in polar format.
So magnitude, phase angle of the first one is 63.43 degrees.
First one.
Sir,
Are you sure? How about the second one? Give it
Yes,
try,
sir,
and I will ask you.
63.43 degrees. But we might need to subtract or add 180 degrees to it.
How about other students? Do they have any opinion on it?
Sir, in both cases, I think the r will be same, 7√5, and the angles will also be same.
Angle would be also the same.
Yes,
So
sir.
the first one's angle is minus 166.57 degree. The first one's angle, and the magnitude is 7√5. About the first one, so
Okay.
-7,
Yes, sir.
-14.
Thanks for your opinion. Some of you are actually correct. Some of you are a bit actually wrong, not completely wrong. Maybe actually, I will give you an idea. Like sometimes we can be actually confused. For the first number, r is the same. -7 square plus -14 square. So we'll get some number, right? So this is the same thing, r1. When I say θ1, the formula is tan inverse y by x. So what you did, you put like this, tan inverse -14 divided by -7. So this negative cancel out. That's why someone is saying this is 60 point something, but that is wrong. So why this is wrong, I can actually clarify. What is -7, -14? This is the real axis. This is the imaginary axis. So -7 is somewhere here. -14 is somewhere here. So this point is here, right? -7, -14j. Do you understand this?
Yes, sir.
Okay, then I said theta is angle with respect to counterclockwise direction with this. All right. So this one is the case. Now I'm not calculating anything. Now think about the other one. What is the second example? 7, 14. If the 7 and 14, I'm writing here, are 2 equal to root over 7 square plus 14 square, would be the same as this, but angle would be tan inverse y by x. Y means 14 divided by 7. So from that expression, this one and this one is also same, but wrong, because in the coordinate, this one, the first one will be represented here, but the second one will be represented 7 here and 14 here. So this is 7 plus 14j. So for this one, angle is only this, means acute angle. বাংলায় বলে হচ্ছে সূক্ষ্মকোণ. So somebody has calculated, right? Tan inverse 14 by 7 equal to how much?
So 243.43 degree. Sir, 63.43 degrees.
Sorry.
Sir, in the
So
first
this is
coordinate,
all
the
right.
angle is in the first coordinate, the
Positive.
angle is 63.43 degrees.
So this angle,
Yes, sir, he's right.
he said 63.4, right?
43 degrees.
Okay,
4.3.
whatever, this angle.
Yes, sir.
Okay.
Okay.
Okay, forget about 3. No problem. 63.4 degree. So for this one, and what is that root over 17 square plus 14 square? I can write down explicitly. Can you check root over 7 square plus 14 square?
7.5.
How much will we get?
So
Can you
7
give me the number?
15.65.
15.65. All right. So this is also 15.65. So if I replace this one in phasor format, so it would be 15.65. From the coordinate, we can see it lies in the first quadrant. So in the first quadrant, the angle is positive, so 63.4, and it's a anti-clockwise direction, 63.4 degree. So this is answer, correct answer. Now check about the second one. The second one, no, first one, -7, -14j. You see, these two lines are exactly on the same line, but on other coordinate, in the opposite coordinate, in the third coordinate. So what is this angle? What is this?
243.
180 degree, right?
180 degrees.
Look, I have been considering what angle? Like anti-clockwise angle, right? So in the anti-clockwise angle, this angle would be total 180 degree plus 63.4 degree. How much? 243? 243.4 degree. So for this one, expression should be 15.65. Now can you tell me, should I put a negative angle or positive angle?
Positive angle.
positive angle.
Yes, because we have been actually going in the which direction?
Anti-clockwise
direction of anti-clockwise direction. Now somebody says, no, I don't like it. I love clockwise direction. What is this angle?
Sir, 180 minus
In clockwise
63.4.
direction? Oh, really? Or 243.4. The whole thing is that. Oh, somebody says 180 minus 63.4. That is correct. Okay, remove this. Which color? Which color? So this angle is the whole angle. The whole angle is 180 degree. So this angle in the clockwise direction is 180 degree minus 63.4 degree. So if someone wants to write, no, I want to write like this, 15.65, angle is negative because now I am going to actually clockwise direction. What is 180 minus 63.4?
116.6.
116.6. Thank you so much. So this one is right. This one is right. Do you understand now? Now, in the beginning of the class, one of my students actually asked me a question like, sir, I don't know when to use plus 180 degree or minus 180 degree. Actually, both are correct. If you go in a clockwise direction, you will get negative value. In the anti-clockwise direction, you'll get the positive value. So there is no such difference. Maybe sometimes we are a bit confused. I can show you in a notebook session. Think about this. This is voltage. This is not perfect. Forget about this. So this is the voltage expression. I can change color, right? I can change color. Give me a second, please. So the current starts from here. Something like this. What is the expression for this? V sine omega t plus 30 degree. Forget about this. Like this angle is pi by 2. This is current. Is current leading or lagging? Here.
Lagging.
Is current leading or lagging? Lagging by how much?
90
90 degree.
Can you read my writings, or I should actually increase?
Yes, sir, I can read it.
My pen. I think I need to increase the thickness right a bit. Okay. I lags voltage by
Leads.
90 degree.
Oh.
Is it correct? Is it correct?
Yes, sir.
Yes, sir.
Okay. Now, there are few students. They said, "Oh, we don't want to actually do like this. We want to do in other way around." Let me check. Choose another color so that we can distinguish. So difficult to choose color. All right. I think I have chosen something. So somebody says, no, I want to do like this. Means, what was the condition for getting, what is it called, like leading and lagging in a formula? So the condition was, if this one is going up, this one has to be also going up, means similar direction. So we had chosen this point as reference for voltage, this point as reference for current. Now someone's saying, no, I don't want to take this. How about this? This is also current, right? If I go in the backward direction. If this one is in the backward direction, it's also going up, right? This is going up. And from here to here, what is the angle? What is the angle here? 360 degrees.
2 pi plus pi by 2.
2 pi plus?
No, sir.
Only 2 pi, right?
Only 2 pi.
Because look, this has a start here, and this completed its cycle here. So the whole thing is 360 degrees. Now, what is this angle from here to here? Means now I want to compare, what is the angle between the voltage and current? 360 minus 90 degree, right? 270 degree. Now someone is saying, I leads voltage by 270 degree. From this actually observation, they said that. From this observation, they said that. Is there any problem? Means, do you think this is wrong or right?
So the second statement is wrong.
Hello? Why?
Because the voltage is still leading. I mean,
this is nothing. Both are correct. The only thing is like this. Check it out. Let's say I have an angle theta, and I went for the anti-clockwise direction. But if I say this angle is positive, somebody says no, I don't want to go here in anti-clockwise direction. I want to go in clockwise direction. What is this angle? 360 degree minus theta. So the basic rule is, if you say something leading or lagging, you can also say the same thing is in the opposite fashion. Means if I say the current is lagging actually voltage by certain degree theta, means let's say current leads voltage by theta degree. We can also say current lags voltage by 360 degree minus theta. Both statements are correct, because what it means, either you are going actually clockwise direction or anti-clockwise direction, and these are the sinusoidal as well as in the periodic system in AC circuit. So we can always go in the backward direction, we can go always in the actually forward direction. But I didn't want to actually mention this one in class so that you people will be confused. Since somebody actually posed the question in the beginning of the class, I wanted to actually just clarify. But please stick to the same formula that we discussed in the first class, because these are the closest one, means is going up, the closest one going up here. So these are the basic idea. It's just for your idea. Don't get confused. Any more confusion so far? Hello? If not, we know this number, right? J square equal to -1. So 1 upon j equal to minus j. These are the very simple things. How about complex conjugate? Do you know anything about complex conjugate? Complex conjugate means we'll be replacing all the I sign by negative I, or negative I into positive I. Means let's say I have a number 2 plus 3i, let's say number A. So complex conjugate generally represented by like this. So complex conjugate of A means only thing will change, I will be minus I, and minus I would be plus I. Let's say 2 minus 5i. Nothing will change. Only the minus sign would be plus sign would be minus, but only for the imaginary number. So this is called complex conjugate. So you can check some examples. So now in the phasor format, how does actually complex conjugate look like? Means if I have a number, the complex conjugate would be the same thing with only the sign difference for the phase angle. So if the phase angle was positive, the phase angle for the complex conjugate should be negative, or the vice versa. Any problem with that? There is a reciprocal things, and you can check there. We know the addition, subtraction, multiplication, division. I think I should actually discuss a bit, and then I will actually finish today's session, and tomorrow the next session probably will be discussing about the phasor in detail. So for the addition, we know the addition for the rectangular form. I don't care about that. So like if I have a complex number, in actually a polar format, so all you have to do is just use the calculator to do such addition. Subtraction, similarly, you can actually do use actually calculator to get some results. But the multiplication and division are quite easy. Like if I have a number, complex number, let's say z1 theta 1 and z2 theta 2, the multiplication should be the magnitude should be multiplied, but the angle should be the addition. And for the division, like this number divided by this number, the magnitude should be just the normal division, but the phase angle would be minus for the case of whatever in the denominator. Like whatever the phase angle of C2, it would be changing its sign for that actually operation. We all know this, right? Or I need to actually clarify more?
No, sir, we know it.
Hello? You know that,
Sir,
right?
we know about
so
it.
Still, if you have any problem, okay, yeah. So if we don't have the question, so probably we'll be actually ending here. But before that, I have a question. Like if I have three numbers, let's say Z1, R1, theta 1, Z2 equal to R2 theta 2, Z3 equal to R3 theta 3. What is the expression for Z1, Z2 by Z3? Can somebody tell me like what is the expression for Z1, Z2 by Z3?
So R1, R2 by
R1, R2,
by R3.
R1, R2 by R3. How about angle?
Theta 1 plus
1 plus
theta
theta
2
2 minus theta 3.
Theta 1 plus theta 2 minus theta 3.
Theta 1 plus theta 2 minus
Theta
theta
1
3.
plus.
Perfect. Yeah, you all know actually. Yeah, you all know actually this thing. So thank you. Thanks here. I'll stop here. I cannot actually start, phasor today. And why did we actually revise these things? Because in the next class, we'll be seeing like we can express any like cosine or sinusoidal term in terms of actually phasor format. Like there is a number, then the angle, and so on. Okay, like this is the phasor domain. We can write down in the sinusoidal term, or vice versa. Like if I have a time domain thing, like these things we have learned in the first class, so we can actually replace in terms of like phasor format, means we don't need to write sine and cosine explicitly anymore. So we'll be actually learning this in the next actually class, inshallah. So do you have any questions so far? If not, we can actually stop our session here. Any question? Hello?
Sir, I have a question outside
If not,
this week. So I will ask
yeah, sure.
later.
Okay, no problem. Thank you. If there is no question, yeah, we'll actually end our session here. I need to go somewhere. Thanks a lot. Thanks a lot for joining the session. I will upload the class recording as well as the annotated class lecture in Google Classroom. See you next week. Have a nice day. Yeah, have a nice day.
Yes, sir. Thank you, sir.
Bye bye.
Thank you, sir.
I love you, sir.